Today is August 6, 2026. This research overview is AI-generated, based on a partial daily collection, and requires human review before its claims are reused. 4 papers are included. 3 concern visual models, selective distillation for image generation, visual reasoning, and socially interactive video. The 4th explores computational design of molecular glues and protein complexes. We will separate measured benchmark results from author claims and editorial interpretation, because these studies use different tasks, metrics, and evidence standards.
The clearest shared idea appears in poly-OPD and OPD-V. A student should not learn equally from every teacher signal. Both train on outputs produced by the student itself, then select supervision believed to be useful. Poly-OPD makes that choice across image generation capabilities using gaps between teacher and student scores. OPD-V makes it token by token, using the probability margin between a positive view containing focused visual evidence and a negative view where that evidence is masked. The connection is an editorial comparison supported by their methods, not evidence that either work influenced the other.
Start with poly-OPD. Its practical goal is to compress complementary text-to-image specialists into one smaller flow model, without forcing all capabilities through exactly the same parameters. Shared attention adapters handle compatible updates, while separate feed-forward adapters preserve selectable preference and composition modes. The authors report that the composition mode raises Gen eval from 67.30 to 73.30 across 553 prompts, using 4 images per prompt. Gains are largest on 2 object prompts, attribute binding and spatial position. DPG bench also improves, from 84.51 to 85.80.
Preference results are more mixed than a single improvement number suggests. On 999 draw bench prompts, image reward rises from 0.922 to 1.168, and HPSV3 from 9.341 to 11.354. But pick score is approximately flat, slipping from 0.869 to 0.866. These are learned metrics, not interchangeable substitutes for direct human preference. Ablations support parts of the proposed recipe within this setup. Removing capability-specific adapters costs 11 Gen eval points, and skipping the off-policy warm start costs 24.1 points. But that also reveals dependence on initialization rather than universal robustness.
OPD-V applies selective teaching to multimodal reasoning. During training, one teacher sees an evidence-centered crop, while another sees a masked version. A student-generated token receives distillation supervision only when the positive teacher assigns it a stronger probability than the negative teacher, and the margin controls the weight. With a Quen 3.5 4 billion parameter model and the same 6,200 example training set used by matched alternatives, the reported mean across 6 visual evaluations is 80.01%. Vision OPD reaches 77.10%, while the base model reaches 64.30%.
Reported gains also appear on 3 other Quen family backbones. Training steps are faster than OPSD in the measured 4 GPU setup, 240 rather than 352 seconds for the 4 billion parameter model. Yet OPD-V also generates much shorter responses, so the timing comparison does not isolate objective efficiency. Another important boundary is privileged localization. Training requires evidence-centered crops. The evidence shows an association among teacher margins, selected tokens, and accuracy, but it does not prove that the margin causally measures visual grounding. No run-to-run variance or statistical significance is supplied.
Hello World moves from still images to video characters that respond toward the viewer during a specified time window while following a camera path. It adapts a pre-trained generator with a low-rank module trained on 156 self-generated interaction clips, then uses temporal attention masking at inference. On 10-second benchmark clips averaged over 3 seeds, it reports a timing score of 81.7 and camera control score of 82.9. The strongest baseline values reported for those measures are 52.6 and 70.0. Those are substantial measured gaps within the author's benchmark.
But the trade-offs matter. Action accuracy is 41.4, below one world model baseline at 50.5, and the uncontrolled base generator at 42.5. Timing improves dramatically with masking, from 36.7 without a mask to 81.7 with video and audio masking, while action accuracy declines slightly. Also, timing excludes outputs judged to contain no interaction, so it is not a combined test of whether the action occurred and whether it occurred on time. A human study with 30 raters favored Hello World across 41 samples, but that is still limited coverage.
The video system is not live interaction yet. It takes 60.2 seconds to generate a 10-second clip, and both camera motion and social actions are scripted beforehand. Long-term identity, memory, and multi-round conversation remain unsupported. There is a limited same-day connection to poly-OPD. Both preserve pre-trained visual generators, use generated supervision, and adapt them with low-rank parameters. That grouping has only medium editorial confidence because poly-OPD is explicitly on policy, whereas Hello World reconstructs a fixed collection of generated clips.
TriGlue is separate from those visual model themes. It estimates an interface between two proteins, generates a candidate molecular glue, and predicts rigid body assembly of the ternary complex. On 94 held-out complexes, average ligand displacement is 5.22, compared with 6.27 to 8.16 for 3 molecular generation baselines. Docking acceptance above the stated DocQ threshold is 35.2% versus 30.8% for deep ternary. Removing interface correction lowers average DocQ from 0.22 to 0.15, supporting the usefulness of that component in the reported computational pipeline.
Those numbers do not establish that the generated compounds work as drugs. The baselines do not solve the same complete joint task. Some receive known pocket information, and the evaluation uses docking, geometry, and predicted binding scores. There is no biochemical or cellular validation. The model also treats protein movement as rigid and compresses the interface into an ellipsoidal summary, limiting structural flexibility. So the author's joint generation framing is interesting, but claims about actual ternary complex formation, degradation, selectivity, toxicity, or practical synthesis remain open.
The most useful next tests are concrete. For poly-OPD, add more teachers, match compute, and obtain blinded human judgments. For OPDV, replace ground truth crops with detected, attention-derived, and random crops, then equalize response lengths in efficiency comparisons. For Hello World, test unpredictable streaming input, frame-level timing errors, persistent identity, and social memory. For TriGlue, compare richer, flexible interfaces and synthesize prioritized candidates for biochemical and cellular assays. Across all 4 papers, broader model families, uncertainty estimates, and stronger human or experimental validation would make the results more convincing.
The concise takeaway is that selective supervision looks promising at both capability and token levels. Temporal masking delivers strong scripted timing control, and joint molecular glue generation shows encouraging computational signals. None of these results yet demonstrates broad deployment reliability, live social interaction, or biological efficacy. Because today's run is partial and historical relationship processing failed, no cross-day connections should be inferred. For the complete evidence tables, limitations, paper links, and open questions, follow the linked daily summary for August 6th.